Hello, my name is Mike Driscoll, and today I'm going to teach you a little bit about Python and how to log with Python. So a lot of people like to use Python and they will do like debugging and just like trying to figure out things using the print statement or the print function, depending on which Python version you're using. And there's nothing wrong with using print. It works really well for certain situations, like working with troublesome server scripts. However, if you use the logging module, you can log to a file and do, post-executable debugging. You can kind of track back through your log and try to figure out what was going on. And so it's just really helpful to check it out and use the logging module. So in this particular tutorial, I'm going to talk about how to create a log, different logging levels, a few of the logging handlers you can use, some of the logging formatters you can use, how to log to different locations at the same time, and several other cool things you can do with the logging module. So let's start by creating a log. One of the easiest ways to create a log is just import logging, and then you can just right away do logging.warning.critical.debug and send a message out. Now, if you don't set a logging level, which we'll get to here in a moment, it'll default to the warning level. And so if we run this, it'll print out warning and critical. And since warning is about the middle logging level, debug will be skipped. Let's go ahead and try running this quick. Right now, because we haven't specified a file or anything, it will just log to standard out. So here we see it logs out warning and critical. It's using the root logger, and then of course the message that we just printed out. So let's talk a little bit more about logging levels. Logging levels there's 5 of them, from the lowest to the highest lowest being debug, the highest being critical. Debug is, as you'd expect, detailed information, usually stuff that you'd only use if you were trying to debug something. You can do informational stuff, which is a little bit more rare. You might have a warning logging level if you just want to warn when like an error has happened, but not a non-critical error. Errors are for when bad errors happen, and critical, well, you'll probably want to log something when your application is crashing, if you can. So the lower the logging level, the more logging levels will be logged. So what does that mean? So if I set my debug level to warning, that means that warning, error, and critical logging levels will be logged, but information and debug will not. Whereas if I set the logging level to debug, all of the logging levels will be logged because debug is the lowest level. Okay, so how do you set a logging level anyway? Let's find out. One of the simplest ways to do it is to create a basic configuration. So after you import logging, you can do logging.basicconfig. Then you set your file name to test.log. If you add your file mode and set it to W, you can overwrite whatever file was already there. Anyway, and then you can set the level. Level equals logging.info. So now if we were to run this code, you would end up getting the informational message and an error has happened, but the debug message wouldn't be in there. So let's switch over to this one, and we'll run back over here, and we'll just try it out quick. So if I run this code, there's no output because now we're logging to a file. So let's go jump over to test. Now I've already run this once just to make sure it works the way I wanted it to, but it'll print out info, root, error, root, just like we saw before with no debug messages. Okay, let's go back to our talk. Okay, so we can create a logger object by doing logging.basicconfig. So, that's not how you create a logger. Creating a logger, use getLogger. So, logging.getLogger returns a logging object, or a logger object, excuse me. Once you have the logger object, you can call functions on it, or methods on it, like setLevel, which lets you set the logging level that way. We switch back over here to number 2 and try it out. We can run this. I've already run it once, so let's go ahead and look at the output. Yeah, so we log the error, And when you log an error, which we're actually going to get to here shortly, it'll log the entire exception. So let's actually look at that quick. When you log an exception, it'll actually put the entire traceback in there for you. So you'll get all the information you need about what the error happened automatically, which is a really nice and handy little tool for you. All right, logging handlers. There are a bunch of different handler types. Some of the more popular ones, and the ones that I've used personally the most, are stream handler, file handler, rotating file handler, and timed rotating file handler. The stream handler is mostly for if you want to make the log directly to your console or your terminal, like standard out, standard error. File handler is to write to disk. Rotating file handler will rotate the log when you hit a certain file size. And the timed rotating file handler will rotate the log at certain timed intervals. So you might set it to rotate it like every hour or every day, that sort of thing. Some of the more rarer logging handlers are socket handler, which sends output to a network socket. SMTP handler for logging messages to an email address via SMTP. And if you run on over to the logging handlers documentation, you can see that there's a bunch of other interesting ones. So like if you're on Windows, you can use the NT event log handler. Or if you're on Linux type of systems, you can use a syslog handler and just log kind of directly to the system log. So, it's worth checking out these different handlers because there's a bunch of interesting ones in here that you just might find useful. Let's look at how the stream handler is used. So we import logging, set the level as before, and then we create a stream handler. This lets us redirect the logging to the standard out, basically. To log to add the handler to our logger, you do logger.addHandler and then the name of the handler. And then when you run this code, it'll go to standard out. So let's run up here and try it out. So when I run this, you'll see some output here. This is my standard out in this particular debugger. So that worked the way we expected it to. Super cool. There's an SMTP handler. I actually tried this out at my job one time. It works really well. So anyway, to use it, you have to import logging.handlers because it's not a default handler that is able to be used like we were able to use the stream handler before. See login.stream handler, you don't have to have the .handlers there. Anyway, once you have the SMTP handler accessible, you can pass it the SMTP server information, your from address, a list of addresses to send an email to, and the subject. It also accepts credentials if you have to log in first. And then you just add your handler like you did before, and then you start logging messages. Now, one annoying thing about SMTP handler is that it will send an email for every single log message. So if you have a very noisy program, you could crash your email server with a bunch of log messages. So I don't really think this is a particularly handy handler to use. In fact, I would probably recommend using Python's email module instead, just to send an email at the end if there's like an error or something, rather than logging messages to SMTP all the time. All right, let's talk about logging formatters for a minute. Formatters will allow you to add formatting to the log messages. So here's an example. You have a login.formatter. You can set the time, which is kind of a human readable format like this for the output. You can set the name, you can log the name of the logger name, and you can log the message. And then of course you have some dashes between them. So this will control the output of the log. And this is a pretty standard format that you'll see in a lot of logs. These are called log record attributes. If we run over to the documentation, you can see that you can log a bunch of different special attributes, like the created time, the file name that you're logging from, the function name that you're logging from. You can log the line number of where it happened. Lots of different things. If you're running a process or running the log in a process or a thread, you can grab its process name or ID, or thread ID or thread name. Just really handy stuff to know about. go ahead and check that out if you have a chance. So anyway, let's take a look at some full-on code for adding formatting. So now we're going to create a stream logger. We're going to format it to use that same format we just talked about. And then we'll try running it. So let's go back over here and try the log formatter. This time if we run this informational message, we'll get a little bit different output. We'll get our little timestamp, the name of our logger, and then the informational message that we added to it. It's printed out right there. Of course, you can change this so it has different spacers or more decorative information in your logger, depending on how fancy you want to be. All right, let's continue. The logging module is thread safe, but it may not work in asynchronous contexts. If you want to use it in asynchronous context, you can use the queue handler as a workaround. I did some digging to find out how to log asynchronously, and I found a couple of different articles. You can try them out yourself on your own time, but I'm not going to talk about them here in this talk. All right, so let's learn how to log to multiple handlers at once. So this example is a little bit longer. We create a function log. All of this stuff is pretty similar to what you've seen already. Create a logger, add a file handler, add a formatter. And then if you want to log to multiple locations, we can set multiple locks to true. And then it will log to your stream handler in addition to the file handler. So if this isn't set to true, you'll only log to the file. So let's go ahead and give this a try. So we'll run it this way first. Get our 0 division error. We continue running. And the first time we ran it, there should only be a sample log file, which we do have. It logs a couple of things. It logs out our little error that we caused. It logs out the critical error that we had. This is a showstopper, but you'll notice that we don't have sample log 2, and it didn't log to standard out at the same time. So let's go ahead and try logging to standard out as well. So we run it the second time through, and you can see that it logged to standard out at the same time that it logged to the file. There's our file here. So that worked pretty much the way we expected it to, and that was really cool. So you can configure your logging a couple of different ways. You saw that we could use the basic config, but there are a couple of other better ways to do it. For example, you could use the file config. File configs are kind of like an INI file. You can set different things like the logger name, its keys, the handlers that you'll be using, the formatter that you'll be using. For the logger root, which matches up with that name, you can set the level to critical, and you can set its handler right there. And then you have your example app logger, and we set its level to informational only, and it goes to the file instead of to the console. And then, of course, you have to set up your other stuff down below. Now, to actually use this code, you can do import login.config, login.config.fileconfig, and then wherever you saved your login config file to. And then you can get your logger. We know that it matches example app because that was in our config file. See, if we go back. Here you can see example app. So that matches up. Then if you run this particular one will only log to file because that's how we set up the example app. It only uses the file handler that we have set. So let's run over here quick to log with a config file. So if we run this, you note this doesn't even really tell us where it's going to log to. You have to go look in the logging config file to find that out. Let's go look in here. Here we go. The file handler is logging to config.log, which we see got created over here. And we can open it up and see that the example app logged the way we expected it to. The other way to create a configuration for your logger is to use the dictionary config or dict config. It's kind of a similar format, but it looks more like JSON. You still have to do login.config for your import. And then you, of course, create it in much the same way. The handlers are a nested dictionary. The loggers are a nested dictionary. The formatters are a login dictionary. You kind of look at the whole thing over here. Make this a little bit different. This one's a bit shorter than the previous example because I didn't want to have the root logger in there. And then to use it, you just do login.config.dictconfig, pass in your dictionary configurator, and then it works basically exactly the same way. So if we run it, we don't get any output because this one only logs to the dictconfig.log file. And we can see that it worked the way we expected it to. Okay. Rotating logs. So to create a rotating handler, you can do from login.handlers import rotating file handler. You create your rotating file handler right there. And you can set your maximum bytes to save. For this example, we're just going to use 20 bytes so that we can see a couple of files get created. But normally you'd probably want this to be multiple megabytes. So you'd probably set this to at least 1,000, probably to even 10,000, because you don't want it to rotate too often. Then you can set the backup count. So in this case, we want up to 5 backup files. As it rotates, it'll create 5 over time, and then rotate and erase them one at a time as well. And then here we will run this code, and it will log a string and then sleep for 1.5 seconds. So if we go over here to the rotating log example and we run this, you're not going to see any output, except over here you'll see rotated log. It's already rotated once, so you got .1, .2, .3, .4. And of course, if you run into them, you can see that it has created different log lines as it's logging. So that works the way we kind of wanted it to. But like I said, in a real example, you wouldn't want to use 20 as your maximum bytes. For the timed rotating file handler, in this case, you would still pass in the path, but this time you tell it how many seconds. So we say seconds, interval is 5 seconds, backup count is 5. You can set it to minute, day. I think there's a week. You have to go look at the documentation, but there's several different settings you can use and make it work the way you want it to. I'm not going to run this because it takes a long time to run, but if you want to try it out, you can see that it'll create a rotating file handler every so often. So let's look at logging with multiple processes. Jump over here. Multiple processes. All right. So this one's a little bit involved, but we'll talk about it. So we import multiprocessing. We jump down here to our main function and create a queue. You have to create yourself a listener for the process, and then you start the processes. And to make this work correctly, I believe you need to use a queue handler, if I can find it. Anyway, let's see if we can just kind of walk through this. So each process, it calls the listener process, configure, and creates a queue, logger, traceback, it's a rotating file handler. That's what I was looking for, the queue handler. You need a queue handler to queue up the logs correctly so they don't collide. At least that's my understanding. So for each worker process, you create a worker process and pass in the queue that we created earlier and append the worker. Then you start the workers. So the worker processes will print that they're working and log different things. And because it's using the queue, it will eventually get into the queue. The queue handler will get called because it's part of the configure worker and it will just make sure that the messages don't collide for you, and it ends up with a nice clean output at the end. So anyway, if you just run this, it takes a little bit to run, but you'll see that it creates a bunch of processes, and then you'll have a file at the end that you can check out. So go look in this, you can see process 6, 8, and 9 all wrote to it. Process 5, 3, and 7 were rotated into another file, etc., etc. It has a process name. It just works really well. Let's go ahead and look at a logging decorator. These are kind of cool and something that I like to use in my own code. So let's see, I gotta find the right example. So I'm sure y'all know how to create a decorator, but we'll go over it real quick. So first, we create a logger with this function. It does pretty much what you've seen before in the previous examples. Get your logger, set the level, add a file handler and a formatter, and then just return the logger. Now we create our decorator. So a decorator is basically a function that accepts another function and modifies it slightly by enhancing it. It actually doesn't really modify the function that's passed to it, but it like enhances it in a special way. So in this case, we're adding logging capabilities. So we accept the function, we create our logger, and we will log any exceptions that happen to it, and then re-raise the exception. We use functools.wraps to keep the function's name and docstring intact. If you don't do that, its function name will become wrapper instead, which we don't want. So let's go over here and apply our decorator. So we'll import our decorator exception and apply it to our zero divide function, which is, kind of a contrived example. Then when we run this, we can see that there's an exception, and if we go over here, we can find out that it caught that exception. Let's go check exactly where it saved it. We didn't set that up right. Let's go ahead and fix this quick. All right. That's my fault. We're going to rerun that again. Run. Now there should be a decorator log here sometime if it refreshes. Anyway, for some reason it's not refreshing, but this is how it works. You'd apply your decorator to it, and then it will log it for you. And that is something that I do all the time at my job. Anyway, some people asked me a long time ago, how do you redirect logging in a WX Python GUI? So we'll just jump on over to my blog where I actually wrote an article about it. So we wanted to redirect Python's logging module to a text control. To get that to work properly, you create your custom handler, your custom logging handler. So login.stream handler, and you set it to use a text control that you're going to be passing in, and then you override the emit function within stream handler, and you can tell it to format your record, and then you write the text of the message. So yeah, the message extracts the log record and then writes it out to your text control. So then, of course, in your WX Python code, you can grab the logger and have it log inside of that, and then set your your text control up somewhere in here. Here we go. You create your handler, your custom handler, and you pass in your text control into that. And that just allows you to redirect the log to the text control. I think I have that right here. So we can just run this live. it's running in the wrong Python. Yeah, let's do that. Let's fix that quick. Hold on a sec. Command line. Okay. So now we have our logging test file. If we run press me, it will log both to the standard out and to our text control, which is really cool. On Linux type systems, you'll see that it gets a little bit. Debian Python is built with the debugging turned on, so you'll see a lot of extra output that you don't normally see if you were to run it on Windows. All right, let's continue. Let's talk about creating a logging filter. This is something I just recently learned about. I didn't know that these existed, but basically they let you do fun and new things. So import logging, subclass it, logging.filter, and then you can kind of filter out different things. So if the function name equals A, then we can ignore it, basically. So we're going to ignore this function's logging entirely. Let's go over here to number 14 real quick so we can kind of see it in action. So we have two functions, both with logger debug in them. We create our configuration, but we add a filter to it up here so that when we run this, it will only log output from the B function, not the A function. I highly recommend looking into the filter because you can make it filter out lots of random things. You can have it check for certain debug messages that you don't care about. Like you don't care about messages from a certain function. You don't care about certain types of messages that contain certain things. It looks like a really powerful tool, but I just don't have a lot of experience with it. But definitely check it out if you have a chance. There are lots of other logging packages out there, like Loggeroo and Structilog. Loggeroo looks kind of interesting to me personally. Can't see it very well in this, but if you go check it out, he describes it as Python logging made stupidly simple. You import your logger. You can go and watch this on your own time, but basically you just add everything that you want in a single line, and then it'll just start working. So you don't have all that boilerplate code that you saw in my examples earlier with the logging module. It just starts logging the way you'd expect it to. So definitely check that one out. I think it looks super cool. Structlog has been around a few years now. It is very interesting as well. I would check it out. It's a little bit different format, and I don't think it's quite as simple as Loggeroo is, but it's totally worth your time to read about. If you have any questions, you can add them in the comments to this video, or you can come ask on my blog too, where I'm going to post this tutorial as well. Thank you so much for watching. I'll talk to you guys in another video soon.